Hello and welcome back, Stats fans. We're starting today with finishing out the 6-3 notes, and these are specific examples of how to use a table and z-scores to get areas and probabilities. So that's what we're going to do. And toward the end, I have example of a calculator, how to use it with the TI-83 or 84 graphing calculators. They will do this automatically as well, so you don't really need a table if you know how to use those calculators. So the very first one is the easy peasy one, and that's what our table in our book gives us. Z is between 0 and 2.34. The table in our book gives the area between the Z0 and the z-score. So first thing I want you to do on your notes is sketch it out. So 0, 2.34, put a vertical line there and just sketch it. And you just have to estimate. This is 0, that's where your mean is. That's 1, 2, and it's a little more than 2. So you can break this up. For our table, we need to break it up 2.3 plus 0.04. That's how you could break up your z-score so that when you look at it in the table, you're going to go down this column to 2.3 and then to the right to 0.04. And this is your area. It's as easy as that. The trick is getting your sketch right and knowing when you add areas, when you add 0.5 to the areas, when you subtract from 0.5, and when you add and when you subtract the areas themselves. So this is 0.4904 and you're done. That problem is finished. I want you to see if you can do the next one on your own. Find the z-score, break it apart, and find the area in your table, and I'll be checking that on your notes. So this next one, you're supposed to try to find the area between 0 and 1.8. And just as a clue, you'd sketch it, 0, 1.8, sketch it out, and then break the z-score up as to 1.8 plus, can you think of it? All right. All right, I hope you got the last one okay. This third example is you're finding the area between 0 and z equal negative 1.75. Do not worry about the negatives here because the area is going to correspond to the positive 1.75. Area is always positive number even when the z-value is negative. This has more to do with the position of your z-value than an actual negative number. So when I look at this one, I'm going to go ahead and sketch it like it would be. Negative 1.75 is over here to the left of the mean, and you sketch that in, you shade that in. And when you look at the table, you just look at the one for positive 1.75. Curve is symmetric, so the area corresponding to z equal negative 1.75 is the same as the area corresponding to z equal 1.75. Notice I put the hundredths in a different color so that you can kind of see when you're going to be doing this. I'm going to go down to the 1.7 on my z and then over to the 0.5, and that's the area. So it's 0.54599. That's it. It's pretty quick. There's not much to it once you get your sketch right. Now this is a different type of problem altogether. The area to the right of z equal 1.11. To the right of this means it's going to go all the way over to positive infinity. So your sketch is going to be at 1.11 and you're going to shade to the right of that. So you can see this goes on and on and on and on and on. Well, you have to keep in mind that half of the area, so from 0 all the way over to infinity, is 0.5. It's 1/2 because the area under the curve is 1. So this would be half, and you're going to find this area, this white area in here, and then just subtract it from 0.5. So the area from 0 to 1.11 is going to be 0.3665. You can look that up on your table. So we know how to find this area. That's the area given on our table. Since we know the area, total area under the curve is 1, and this would be from 0 on over, would then split it in half, so it would be the area to the right of 1.11 is going to be 0.5 minus the 0.3665, and that's going to give you 0.1335. So that's finding a little tail there. So this is a tail one. I want you to try this one and see if you can figure it out. To the left, it's going to be the same concept, but you're going to be going all the way to the left. If you have trouble, see me tomorrow. Here's yet a different type of problem. It says find the area between z equal 2 and z equal 2.47. This is one of those that I would find this the most difficult, but it's very easy on a graphing calculator. But when you're using tables, you're basically going to find the area between 0 and the larger z-score, and then find the area between 0 and the smaller z-score, or the one that's closer to the mean, and subtract the areas. So when I look at the table, the area between 0 and 2.47 is 0.4932. And the area between 0 and 2 is 0.4772. So what you're going to do is subtract those two, and always subtract the smaller from the larger. So the area between 2 and 2.47 is going to be 0.0160. Areas are never negative. Always subtract the smaller value from the larger. Alright, I want you to try the same type of problem. Remember, it doesn't matter if the z-scores are negative. This gives you position. So draw the picture, sketch the picture, and find the area. And show me how you got the area. Here's one where we need to add the areas together. It says find the area between z equal 1.68 and z equal negative 1.37. If we sketch that problem, we would have area on this side of the mean and area on this side of the mean. So you should be able to see, you know your table gives you the area between 0 and 1.68 and the area between 0 and negative 1.37. Then all you have to do is add them up. So when you find both of the areas, you're going to add those two together and get a total. So this is going to be 0.8682, and that's it. Here's one that goes to infinity, and this is yet a different type of problem that you'll see. You know you can find this area from 0 to 1.199, but they want you to find the area all the way over. Recall that since this is symmetric, all the way from the mean all the way to the left is automatically 0.5. So all you have to do is find this area from the table, which is what our table gives you directly, and then add 0.5. And that's it, 0.9767. You're done with that one. Example 6-10 is just like this one, and 6-11 is a combo of the tail one. I want to see if you can figure those out on your own, so give those a try on your own. Bum-ba-da-da! Time for technology. We're going to use our graphing calculator to do these different calculations. Remember that the calculators of today a lot of times have the tables built right into them, so you can just have your calculator and bada boom bada bing get the answer. So here's how we're going to use that TI-83 or 84 plus calculator. The area that this calculator gives us is an area bounded on the left and the right by vertical lines. So that means we're going to have to put in two different z-scores in order to find the area. With the TI-83 or 84, you want to pick push the second and the vars button and then select number 2. On the calculator, the vars button is right below the arrows here, so it's right below here. And enter the two z-scores separated by a comma. So here's the syntax. You're going to have the left z-score, comma, the right z-score. So the syntax for when you have infinity or negative infinity is E99. So you put E99 for positive infinity and negative E99 for negative infinity. So to get the E99, you do second and then hit the comma button, which has the EE above it, and then 99. That's how you can put that into your calculator. Let's look at one of our examples that I've already done, which is example 6.6. They wanted you to find the area between 2 and 2.47. When we found this answer, we actually found the probability of z being between 2 and 2.47. If you remember from the previous lesson, the area is the probability. So to use the TI-84 graphing calculator, all we have to do is press second, vars, and then number 2. So this is what should show up on your screen of your graphing calculator. Normal, CDF, open parenthesis, and then we're going to input 2 as the lower, that's the lower z value, and 2.47 as the upper. And so you'll have 2, 2.47, mean should be 0, and standard deviation, which is little siggy, I think I'll call it little siggy, should be 1, and then paste. So this is, I believe, the TI-84 screens that you see. After you select paste, you hit enter, enter, and you end up with this. So this is what would show up. Hit enter and bada boom bada bing, it's like magic. So there is your final answer, 0.01599444012. The area, a couple things to remember with these is the area under the normal distribution can also be thought of as a probability. Now I could have put that last answer as a percentage if I had wanted to. And the area between z equals 0 and 2.32 will be the same as the probability of selecting any z value between 0 and 2.32. For probabilities, we use special notation. For example, to find the probability of any z value between 0 and 2.32, we use this big P out here. Take a big P and put the z between these. So that's the notation. In a continuous distribution, the probability of an exact v-value is 0. You don't really need to know this. It's just that whenever you're using z-values, you're finding the area between two of them, whether it be the mean, whether it be another z-value, whether it be all the way to the right. Also, what you need to keep in mind is that the probability, if you put this less than or equal to, it makes no difference. And that's because the vertical line, it doesn't have any area. So that's all you need to know from this one. Let's try to find the probability for each of these between 0 and 2.32. I'm going to put in, I could look at the table or put it into the graphing calculator, get 0.4898. So you might want to mess with that a little bit. For p less than 1.65, this is one of those, if it's less than 1.65, you're finding the area all the way to the left, so it's going to negative infinity. So here's what you should put into your calculator. -1, the E99, remember E is second and then the comma button, and then 99, the upper would be 1.65, 0 for the mean, 1 for the standard deviation, enter, 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 and you'll end up with 0.9505. Let's do one to the other side. Z bigger than 1.91 means Z is getting bigger and bigger and bigger and bigger all the way to positive infinity. So you're going to put positive 1.91 here and go to positive infinity on the other side. You didn't need the negative in front of this one. I just did it straight. And you'll end up with 0.0281. All right, we have one more problem to get through. This is a backwards one. You know, in math, they always want you to learn something going forwards and then going backwards. So this time, they give you the area. So and they want us to find the z-score. So here's the way the question is worded. Find the z-value such that the area on the standardized normal distribution curve between 0 and this z is 0.2123. Now, this is perfect for our table. I'm not quite sure how you do it on the calculator, but no problem because the table is going to be a snap. So what we want to do is find the area in the body of table E, then read the corresponding values on the left-hand side and the top, add them up, and that'll give you the z-score. So here's what I'm talking about. Here's our table, and we're looking for 0.2123 in the area of the table. So ding, 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 there is 0.2123 right there. So we're going to look to the left, 0.5, and look above that 0.2123, add those two together, and bada boom, bada bing, that's our z-score. Doesn't get much easier than that, folks. So when we add that together, we're going to get z equals 0.56. And that's all she wrote. I hope this helps with doing the problems and learning how z-scores and probability and area under the curve, how they're all related. I will see you tomorrow.